Good morning, everyone. My name is Timothy Lee Grant, and this is the second part of a series which I am making on linked lists. So in the first video, I talked about kind of the conceptual idea of what a linked list is, and I used a metro station to kind of illustrate this example. So I talked about each node is an actual station. So you're on the station, and at this particular station you have some data or some attraction, right, at this station that you can go to, and you can also get on the train and then go to the next station, and that's represented here. But if you're on the metro, you can't go from one station all the way down to the other one without passing through each link in that list. So I kind of made that illustration and connected it to how you're actually setting up a node in a linked list. And then in the second part, which is this one, I want to talk about how you actually go about creating this linked list and manipulating some of the data. I actually made a video about it yesterday, but I wasn't really happy with the way that it turned out because I didn't feel like I did a very good job actually explaining the concepts. I ended up just writing a whole bunch of code on the board and then explaining it as I was going, but I don't really think that that was a very effective way of teaching. And I know if I was watching this when I was first learning how to do linked lists, it would have been kind of difficult for me to actually understand what was going on. So I'm going to try a different approach in this video. I've been thinking about how better to actually represent this idea, and I think I have an idea, which is I'm going to show it more visually. So I'm going to show actual objects being created and then the line of code which associates with that particular action which is being taken. So if you guys would let me know if this is a better method for you and if it was more clear for you, I would really appreciate feedback one way or the other. So anyways, right, we have a struct node. So this is a struct, okay, and it has three parts to it. Number one is int data. Second one is string name. And then third one is struct node pointer next. Okay, so these two, the first two variables, data and name, these are kind of like the attraction at the actual subway station, right, at your particular station. So in this case, this node is going to have data, which is Oregon State University, and then an integer, maybe the ranking, right? So at this station, you have Oregon State University. Here's the attraction. Here's the data which you're trying to store. And you have to remember, linked lists, the entire purpose is to store data. So you're creating this structure, and you're going to be putting data in. That's the entire point of a linked list, is to be able to go in, put data into this linked list, and then to later go on and search through it and pull out the data which you're looking for. So in this particular case, Oregon State University, that's the actual data which we're storing, and then we might have a ranking as well. So that's how you create each of the station. But let's actually go through like how you initialize the list and everything. So here we go. First thing that we need is a pointer. So let's represent that with a triangle, okay? So here is our pointer. Now, what I said pointers do is they store an address and you are able to go to that address, right? So you have an actual data, a variable, which in that variable you store an address. And through that, if you use the dereference operator, you are able to go to that actual location in memory. So we created a pointer here, so let's put that into code. How do we do that? Well, struct node pointer, and let's call it head. All right, so here we go. in this line of code, I just created this pointer. So struct node pointer, and remember this asterisk right here is not the dereference operator. When you see an asterisk in the context of a declaration, it means this variable right here is going to be a pointer variable. Now what is it going to point to? It is going to point to a struct node. So this right here is a pointer variable. That's why it's a triangle. And it is going to point to struct node. And it's going to be called head. So I'm going to put head right here. Okay? Now, nothing is in it. Right now, it's not really pointing to anything. It's just pointing to garbage. So how do we connect this head to a node? And right now we have not created anything, by the way. The only thing which we have created is this head that points to kind of nothing. So we need to create a node. Okay? So let's actually create that node. Okay? So how do we create a node? Right now, we do not have any memory allocated to create a node. And the reason why, actually so let's see. I will create some memory. I need to allocate some memory, okay? The way we're gonna do this is the malloc function. Okay, so here we go. This malloc function, what it does is it says, I want you to allocate some amount of memory. Okay, bam, we just allocated memory so that we could actually create a node, okay? Now, here, when you do this declaration, the compiler actually allocates memory. And this happens at compile time. So when you compile it, the compiler will look at it and see this declaration and say, okay, cool. I know that you want to create a variable called head, and it is of type struct node pointer. I know how much to allocate in this particular instance. But think about a linked list. We don't know at compile time how many links we want. We could just have 1, 2, 3, 4, but we could have 5, or 10, or 50, or 1,000, or 1,000,000, right? So we don't know how many links we actually want. So that's why we have to do what's called dynamically allocating memory. So this happens when when you compile your program, okay? This malloc says, okay, while your program is running, go and find some amount of memory. And I'm going to talk about how much memory in a second. It has to do with this right here, okay? But go find some memory and allocate it, okay? Now, how much memory? Well, that's what's passed in right here as a parameter, okay? So now what we do is we use another function which is called size of. So we're passing in a parameter, and the malloc function says, how many bytes do you want me to allocate? Okay, well, we have a function that's very helpful about this. It's called size of. And what size of does is it takes in one argument. In this case, it's struct node, and it returns how many bytes are that particular data element is. So we could put int right here. So size of takes one argument. We could put int right there, and then the size of function would return the number of bytes that an integer value is on your particular machine. Or we could have a float, or a long, or a double. And in this case, struct node was declared up here, and this is just a variable type, right? So we pass in this struct node into the size of function, and it says, okay, it finds the amount of bytes that this particular element is, and says, okay, I'm going to return the number of bytes. Then malloc is going to take that and then allocate that number of bytes in memory, okay? But head now was declared a struct node pointer, so it needs to point to a struct node. So actually what we need to do is kind of cast this. So I'm gonna write here struct node pointer. Okay, so I don't know if you guys can see it. Struct node pointer. Okay, and that goes right here. So you cast it, and then what malloc does is it allocates the memory. Cool, we did that. Then it returns the address which it allocated the memory at. So it is going to return a memory address. Okay, that's exactly what a pointer variable stores, a memory address. So then we just cast that memory address, because we have to tell it what it is, right? At that point, it doesn't know what that memory it doesn't know what this actually is. What is this? It's just a certain number of bytes allocated. We don't know what it is. So we cast it as a struct node pointer, and that causes it to go from this random circle, and I'm going to draw each node kind of as a box, okay? Okay, so kind of like this, with name, and then data, and then next. Okay, so now we have this right here. Okay, cool. So now let's kind of set things up a little bit more. I'm going to erase this just for space, but you see the lines of code and what we've done. Okay, so we've created this memory, and it has 3 elements: name, data, and next. So now let's kind of access this. We said head, so head points to this, okay? So what does this actual line do? It takes head, which stores the memory address, okay? Here's a address operator, right? Well, it would just be 1, but it has an address, and then this says go to it. Go, right? Take the subway, take that train, actually go through wherever this is pointing to, actually go to it. Okay, so we can take advantage of this. Now, do you remember I talked in my video about pointers about the arrow operator? So let's revisit that as well. Head, and then arrow, and then data. Okay, let's say equals number 1. Okay, so what does this line of code do? It takes this first one, which is a pointer. This is always going in the case of the arrow operator, this particular element is always going to be a pointer, because what this arrow operator means is this. Head with the dereference operator dot data equals 1. Okay. So these two statements are identical. This arrow operator means take this element, dereference it. So this is a pointer. It means go to the place which this pointer has. This pointer has a memory address. Go to there, actually go to that address, okay? And then access this element right there. Okay, so these two are identical. Whenever you see that arrow, you can just think, okay, well, this is a pointer, and it means go to this, and then access this member variable. Okay, cool. So now, let's look at this and figure out what it did to the corresponding node right here. Okay, so head, bam. Go to data, or actually go to this location, which is the entire struct, and then access data, and then assign it number 1. So what happens is this data equals 1, like that. Okay? So now let's put the name to Oregon State University. So what we're going to do is, and if you're using correct C syntax, you're going to have to use like string copy. I'm going to write a little bit of pseudocode just so that it's easier, right? So I'm going to go head and then name equals OSU. There we go. So what does this do? It says, okay, I'm going to go to head and then go to the location, or I have head, and I'm going to go to the location which it's pointing to, which is this struct, and then I'm going to access the name member variable and assign it OSU. So now name equals OSU. Okay? Now, we have this next variable. And next is actually a struct node pointer. And I said that I was going to represent struct node pointers as a triangle. So let's do that. Here's the triangle for next. Okay, cool. So now what do we want to do? We want to connect this variable to another link. And we have to think about this a little bit, because how are we going to access this particular one? We could do head, arrow, and then next. That works, but what we want with this head variable is we want a variable which we can have that always points to the front of the list, okay? The very first element in our linked list. Because if we move this pointer to somewhere else, we actually don't have a way to get to this node. Does that make sense? We need to know where the first element is. You have to know how to get onto the subway before you can even ride it, correct? And then if you get to MIT, well, how do you get back up to OSU, assuming that these are all one directional, right? Like if you're at MIT, you can't get to Oregon State University. So you always want a variable that is continually and only pointing at the first element in your linked list. Okay? So let's create another struct pointer and call it current. Okay? And we're going to use current to kind of iterate through. We're going to use that to actually like travel through our list. So let's do that. So same concept as when I did the head. So it's going to be struct node pointer, and then I said current. Okay, so I just created another pointer called current. Okay, there we go. So now I want it to point to the first location as well. That way we can just kind of travel through and get a variable that will allow us to actually go and kind of fill this out. So let's say current equals head. Okay, so what is current equals head? Here's current, and head is a pointer, and it stores a memory address. This memory address right here, which is in this memory address, or in this variable, is a memory address of the first element. And then if we use the dereference operator, that means go to it. Okay, so but at this point, this head just contains a address. Okay, and now I'm storing that same address in the variable called current. So what does that mean? That means current points to this element as well. Now notice it doesn't mean go to, right? This arrow kind of just means it's connected. There's a connection, right? Okay, cool. So current and head both point to this first element. Very good. Now let's actually create that second element. Okay, so what do we want to do? We have this next variable. That's kind of like what I was saying with how we want to go and have a train connecting this station to the NYU station to the MIT station. Right there is a node pointer, and this is kind of like your train. You can go and take it to the next one. So let's kind of use that. Let's go. Okay, current next equals, and now if you notice, what do we want it to point to? Because right now next is kind of pointing to nothing. Well, we need to use that exact same methodology of we need to create some memory. We need to allocate some memory. Okay, so, and this has to be, you have to have a pointer, so struct node pointer. You have to do that casting, and then malloc size of struct node. Okay, so current, yes, this points here. So then when you use this arrow operator, it means go to that element. So go to it, access the next element, okay? And we're changing this next element. And what are we changing it to? We are allocating memory, boom. Then storing that memory into the next variable. So we're changing this next right here, and we are allocating memory and returning, this malloc function returns the address which it just allocated the memory, and that is casted as a struct node pointer. So it returns memory, and then that memory is stored in a pointer variable. Because remember, pointer variables, that's their entire job, is to store a memory address. This malloc returns a memory address, so you can accept it in this next pointer variable. Okay, cool. And because we cast this, it's no longer just an amorphous blob of nothing. It is now another struct node, and now that's pointed there, which has a name, which has data, and also has a struct node pointer called next. Okay, cool. So now what do we want to do? Let's take the train down to this one, which is right here. So I want to move this current, and I want to change it from pointing here to pointing here. I want current to point here. How are we going to do that? Well, current is right now pointing here, right? So what would happen if I go like this? Current equals current next. Okay, current equals current next. So we are changing this current value, okay? And what are we changing it to? We're changing it to this value right here, which is what? So go to current, then this arrow operator means go there, right? Go to this node, so wherever current is pointing, go to wherever current is pointing, which is in this case, this node, access this next variable, okay? And then access that data, which right now that data is storing a memory address, which is this right here. It's storing this element's memory address. So what we do, I'm just going to say it again because repetition is pretty good to get in people's mind. Okay, so we are reassigning this current. What are we reassigning it to? We are going to, and then accessing the next, the member variable next, and this is going to contain some data, which in this case is the memory address right here, correct? See, next is pointing to here. And then we're going to assign it to current. So that changes current, and it no longer points there, it points here. Do you see that? So current is changed from, instead of what we're changing it, we're assigning it. What are we assigning it to? Well, it was pointing here, so this arrow means go to current, which it was pointing to here, access the next element, which is right there, which is a pointer, and this pointer contains the memory address right here. So access that memory, right? And then just assign it there. Bam. There we go. Now current points to this element. See how we can kind of travel, just like a passenger comes here. We were right there. Then we took the train right there. And that's how you can take the train, is you go where I am now. So where I am now, go to the next. That's how you travel the train. This current is kind of like your the passenger who's actually traveling through the train. Current, where I am now, go to the next one and assign that to be current. Okay, cool. So now we have aligned current to be this one. So now we want to set up this to be NYU. Well, you should have a general idea of how this is going to go, but I'm going to write it out anyway. So what we're going to do is current, and then data equals NYU. Let's say it's ranked number 5, okay? And then let's say current name equals NYU, okay? And then, so what happens is current data is equal to 5, so data equals 5, name equals NYU, and then next now is kind of out in the air, right? Okay, well, we can do the exact same thing for MIT, and we can do the exact same thing for UCLA, right? What we can do is just do, and I'll write this in one line of code. So current equals, hold on a second. So let's first actually create this memory, because I said that I want to go through it methodically with images. Okay, so create this. So current next equals, and I'm not going to cast it. You know that you have to cast it. So cast it, and malloc, and then size of struct node. So that creates this element, and it returns a memory address, and that memory address is stored at go to current. Okay, go to current, it's right here. Access the next variable and assign that memory address to this variable. Okay, so now next, this element's next is pointed to this memory address, and we cast it, so it is now not just an amorphous blob, but it is a struct node. There we go. And then it has a name, data, and next. Okay, so I think you guys know how to now do the name, data, and next, but I'll just do it one more time just so that we get more practice. Okay, so I want to take this current and align it, to point here. So how am I going to do that? Well, here we go. Current equals, I want current, and so I want it to be where I'm pointing now, that's next variable, right? So go to hit, access this next, and I want that to be what current is. So, very simple. Current next. Okay, cool. Very good. So now current is pointed here. And now you can just do current arrow name equals MIT, and then current that's an arrow data equals, and then MIT, well, that's probably number 2, so that one's going to be rank number 2. Okay, so current data MIT. All right, so now there's one other thing that we normally like to do every time that we create a new node, which is this next pointer right here. We don't really want it to be pointing to nothing. We don't want it pointing to random garbage. So normally when we create this new link, we will say current next equals null. And what that does is, instead of just pointing nowhere, it points to the null vector, or points to 0. And the reason why this is really useful is because now we can kind of traverse, we can start at head and kind of traverse through this until we hit next. So I can reassign this current. Let's iterate through our linked list. Let's just show how that would work. So I want to start at the first and just go through. So I've already created it. Let me talk about what I'm actually doing. Okay, so I've already created this linked list. I have head points to the first element, and there's 3 elements. Okay, so now I want to traverse through my data structure, and I want to, let's just say, check if it is UCLA, if we have UCLA in our list. So let's do that. Let's start at the first element. How do we do that? We have this traveler, which we called current, and we know where the first element is. So let's just do it. What do we want? We want this to no longer point to here. We want it to point to the same location which head is pointing to. How do you do that? Current equals head. There we go. There's the associated line of code. Current equals head. Current equals head. There we go. All right. So now let's traverse through our list. So we want to keep going, right? Until we hit null. Does that make sense? We want to start at the first link and keep going. Oh, we hit null. That's how we know that we're going to stop, is when we hit null. So we can do while current is not equal to null. And now, when you actually are looking at other people's code, remember that null is 0. So if current is not equal to null, it means that it is not 0, right? So what some people could do is they'll put a not sign there. So I'll show that, what that would look like. So it would be current like that, and then a not sign, right? So while this current variable contains anything other than 0, keep going, right? But I think it's a little bit more clear if I do while current is not equal to null. Okay, so we are going to keep iterating through this. Okay? We're going to keep iterating through this. And what do we want to do while we actually iterate? I'm going to move this while loop so that you guys can see it better. So here's while, and then, okay, cool. So here's my while loop. So current is right here. While current is not equal to 0. So I said we want to check for like UCLA, if UCLA is in our actual list. So what we can do is we have to keep traversing until we hit null. Okay, so while we're at this, we are going to check if name is equal to UCLA. So if, and then string compare, and then string compare takes 2 elements, the data, so that is going to be current. We want to go to current, go to this element, and access the name variable, okay? And then the second is we want the name UCLA, like that. Okay, so if string compare, if your current, the place that current is pointed to, if that name variable is equal to UCLA, you can maybe return and then true. Okay, so well, I guess what we're trying to do in this right here is we're checking to see if this UCLA is within our list. If it is, we are going to return true. If it is not, we are going to return false. So we're iterating over, we're going to just travel through the metro station. We're going to keep going, keep riding that train from here to here to here, although these have not been created, right? So we're which is going to travel from here to here to here. And then each time we're going to check, so we're going to go to this station. Well, we're going to first go to this station. We're going to check the name. If it is UCLA, then we're going to return true. If it is not, we are going to travel to the next station and see if that's the name. And then we're going to keep doing that until we hit a null in the next, because that would mean that, oh, it's not in the list, and so we need to, or that we've hit the end of the list, and therefore it's not in the list, so we can say it's UCLA is not in the list. Okay, so we're comparing, and we're going to return true if it is in there. If it's not, what do we want to do? We want to go to the next one. So there's that if statement. The next one is going to be current equals current next. Okay. So then it goes, and it just goes to here to here. Like that. There we go. And then it hits this, okay? It assigns current to be here. Then it comes up to this while statement. It checks, is current equal to null? No, current holds the memory address, which is associated with this station, or this node. So it's not null, so it comes in here. Checks the name element, and it says it's NYU. So this if statement does not trigger. Okay, then it goes down. Current equals current next. Go to current, access the next variable, and then assign it to current. So now this no longer points there, points there. Cool. So then comes up here. Well, current is not null. Is current null? Nope. Points right there. All right. So go into the while loop. Check this if statement. Is it equal to UCLA? No, it equals MIT. Okay? So then come here. Current equals current next. Well, current, we're going to change this, equals current, go to current, next, null. Okay, so now current is null. Comes up here, says current is null, does not run this if statement, and now you can return false. Does that make sense? Because we've hit the end of the list. Return false. Okay, so that's how you create a linked list, and that is how you traverse through the linked list. In the next video, I'm going to be talking about how you kind of manipulate the linked list. So let's say you want to take NYU out. You don't like NYU, and you just want Oregon State University to connect straight to MIT. How do you actually do that? So in the next video, I'm going to go over that and talk more about how you can do the manipulations, because you have to, you think about it, like if you just do this, well, this element now still exists, so you kind of have to delete this one. So I will talk about that in the next video, and I hope that this video was a lot more clear than the last one I made. I was very unhappy with the way that the last one turned out. I know, like, if I saw that video, when I was first learning how to do linked lists, I would have been fairly confused, and I just feel like I didn't do a very good job, and I wasn't very proud of that video. This one, I really like this visual way of explaining how to do linked lists. I think that this is a much better way. I was really thinking about it all day today, like how can I actually make a better video to more clearly explain to people how to actually do it. If you guys could let me know if you liked this way of teaching, this style of teaching, I would really appreciate your feedback and be able to adjust my videos to better suit you guys for what you guys prefer and what's helpful for you. So please give me feedback. I guess subscribe if you want to. Give me a thumbs up if you want to as well. That would be nice. And I hope that you guys have a wonderful day. So see you guys later.